Okay, let's go here. All right, 3, 5, the angles of a polygon. Okay, so far we've talked about the angles of a triangle, and in a triangle we learned that these 3 angles add up to 180 degrees. Okay, now we're going to figure out about all sorts of polygons. There's a square, there's a pentagon, there's a hexagon, something. Oh, that's terrible. There's all these different shapes. Okay, so let's get to it here. First off, there's 2 different flavors of polygons. There's the convex, and then there's the non-convex. Convex, what that means is there's no point inside the polygon. So for example, a square, all of the points, this point, this point, this point, this point, or let's think about any old shape. It doesn't have to be, it could just be something like that. But all of these points all are on the outside of the polygon. Okay? In a non-convex, there's a point inside. So right there. Do you see the point I'm talking about? Yeah, right here. This point is actually on the inside of the polygon. So we'll ask you to recognize these, but we're not going to do much more with them. Most of what we do, we're going to be working with the convex polygons. So let's start working with this one. So I've got a hexagon drawn here, and that red line, we're going to call that a diagonal. So you can draw a diagonal in a polygon if you just connect 2 vertices. Now you're not going to be able to connect adjacent vertices because that's the line. It's already connected. But if you're going to go through a polygon, you're going to connect 2 vertices, 2 corners. Okay, so we're going to use this diagonal. We're going to use some other diagonals to figure out how many degrees are in a polygon. And here's the question. What's the sum of all the angles inside a polygon? Okay, so we're talking about this angle, this angle. We're going to add all these angles up. We need to add up all those angles. And here's what we're going to do. I'm going to draw in a diagonal. Okay, so I drew in a diagonal, and by doing that, look at what shape I made. That's a triangle. And we just learned that in a triangle, there's 180 degrees. So if you add up this angle, and this angle, and this angle, those 3 angles are going to add up to 180 degrees. So this is 180 degrees. Now if I did that again, let me do this in blue. Okay, another triangle appears, right? This angle, and this angle, and this angle. Again, 180 degrees. Let's keep going with this. Another one. I've got an angle, an angle, an angle, 180 degrees. And then there's that last triangle over here. Oops. So all these, oops, that angle and that angle and that. Okay, so in those 4 triangles, the 3 angles in each one make up 180 degrees. So for this example, how many degrees are in the big thing, the hexagon here, the thing with 6 sides? Well, if you look at it, you've got all these are added up. This one and these are added up. It's 180 degrees plus 180 degrees plus 180 plus 180. So there's 4 of them. this starts getting us to our theorem here. There's 180 degrees so 4 times 180, 720 degrees in the angles in this hexagon. So this leads us to our theorem here. The sum of the measures of the angles in a polygon with n sides, right? 1, 2, 3, 4, 5, 6. This one has 6 sides. We multiplied it times 4. So here's what happens. It's take the number of sides, subtract 2, and multiply it by 180. If you take the number of sides and then subtract 2, that's how many triangles you're going to make. Just for example, here, I'll go back to that in a second. Simple example here. Quadrilateral, it's got 4 sides. If I draw in my diagonal, I've made 2 triangles, right? Originally it had 4 sides. When I draw in my diagonal, I cut it into 2. So that's 4 sides minus 2. So it's 2. So to find out all these angles, added up, it would be 2 times 180. 360 degrees. Okay, so that's our theorem when we're working with the interior angles of a polygon. Take the number of sides, subtract 2, and multiply by 180. Okay, now we need to come up with the next theorem. That's for the exterior angles. So for example, if I extend this angle, if I extend that side, and I extend this side, and I extend this side, and this side, what do all those angles add up to? Triangle. Okay, let's get some numbers here for these examples. Let's just pretend this is a square. Okay, let's say it's a square. So we know these are all 90 degrees. And if those are all 90 degrees, then the exterior angle is going to have to be the supplement of that. So the exterior angle is going to also be 90 degrees. And I've got 4 of them. So in this case, the sum of the exterior angles, 360 degrees. Let's look at the triangle. Let's pretend, or let's state here that this is an equilateral triangle, equiangular triangle as well. So if that's an equiangular triangle, we know that all 3 angles are 60 degrees each. So if this is 60, and 60, and 60, that means this exterior angle has to be the supplement because I've made a straight line. So the supplement of 60 is 120. So I've got 120, 120, 120. Are you seeing the pattern yet? If we add up those exterior angles, 360 degrees. Okay, let's see if it holds true here for this hexagon. Now, we just did some math already. We worked it out, and we figured out that the sum of those angles is 720 degrees. So let's say that all of the angles are the same. So that would divide evenly into these 6 angles. So 720 divided by 6 is 120. So all of these angles are 120 degrees. So if all of these are 120 degrees, then what are all the exterior angles? Those must be the supplement of 120 and the supplement of 120, that's right, is 60. So these are all 60 degrees. Okay, so now one more piece of math here, 60 degrees, and I've got 6 of them. 6 times 6, 36, that's right. Okay, so you've seen the pattern. Wow, that's a lot of numbers on there. And we figured it out. It's always going to be 360 degrees for the sum of the exterior angles. Okay, that was a lot of work. Last little bit of info here. When we're talking about regular polygons, that means that all of the sides and all of the angles are congruent. So when we were working with these, we had to make our math work out nice and neat. We did assume that these were regular polygons. The sides and angles were congruent. So if I say a regular quadrilateral, I'm talking about a square. If I say a regular hexagon, a regular pentagon, a regular triskaidekagon, or a nonagon, or whatever it is, I'm talking about a regular one. I'm talking about one that has all congruent sides and congruent angles. Not regular, just a regular, just an unregular, the angles are not all the same. It's still going to hold true, though, for these ones that are not regular. It's still going to hold true that all the exterior angles add up to 360, and it's still going to hold true that the interior angles will add up to n minus 2 times 180. Okay, that is it. All right.